Okay, so this is going to be my first video for section 3.4, which deals with quadratic functions. So in this video, we're going to talk about what's the notation and some of the definitions related to quadratic functions, and then we'll also talk about the shape of the graph of quadratic functions. So first of all, let's go back down memory lane because we've seen this word quadratic before. We talked about quadratic equations before, and we actually had a formula called quadratic formula. So let's remind ourselves, what did the word quadratic mean in those senses? So a quadratic equation is an equation of the type ax squared plus bx plus c is equal to 0. Or something that can be rewritten in this format. And so the main thing that makes it quadratic is the fact that the equation has an x squared, or a degree 2 term. Because if this wasn't here, if we just had bx plus c, that would be a linear equation that would correspond somehow to a graph that was a straight line. So in this section, we're going to be talking about quadratic equations and also quadratic functions. So what's the function equivalent of this? Well, it's just f of x equals something that looks like this. So a quadratic function would be something of the form f of x is equal to a number times an x squared plus a number times an x plus a number. So same formula we've seen before, ax squared plus bx plus c, only now instead of being equal to 0, we're saying it's equal to f of x, or it's equal to y, because remember f of x is the same thing as y. So I could also write this function as a graph as ax squared, y is equal to ax squared plus bx plus c. Okay, so let's look at, so that's the notation behind a quadratic function, is f of x equals ax squared plus bx plus c. Let's also talk about some shapes. So let's look at some examples. So let's look at maybe 3 examples. So I'll start off with the simplest possible quadratic function. It needs to at least have an x squared, but I don't want to have anything more complicated than that, just x squared and nothing else. And then I'm also going to try and graph a couple of other ones. I'll graph a g of x, which is going to be 3 times x squared, and I'll graph an h of x, which is negative 1/2 x squared. Okay, so I'll try and come up with a table to come up with a graph for each one of these. So again, the f of x, or the g of x, or the h of x is representing y. So when we make our table, we have a column for x, a column for y, which is going to be represented by f of x. So let's make our little table for each one. And as usual, I'm going to start off in the simple way. I'm just going to plug in numbers from -2 to 2. I'll leave a gap in case I end up deciding later on, oh, I didn't actually get enough points to figure out what the shape looks like. So if I need to plot some more points, I can plot some more points, like plug in -3, -4, and so on. Okay, so when I plug -2 into x squared, we get -2 squared, which would be a positive 4. -1 squared, which would be a positive 1. 0 squared, 1 squared, and 2 squared. And hopefully we've seen these numbers before. These should be starting to ring some bells. If I plug them into this equation, I'm maybe gonna make this video shorter than it otherwise would be. Instead of actually plugging -2 in there, I'm gonna realize that these two are related. We're still going to have to take -2 and square it, but then we're also going to multiply by 3. So instead of doing 3 times -2 squared, I'm just going to say, well, that's actually 3 times my previous answer, and 3 times 4 would be just a 12. And if I do the same thing here, 3 times my previous answer, 3 times 1 would just be a 3. And 3 times my previous answer would just be a 0. And 3 times a 1 would be a 3. And 3 times a 4 would be a 12. But again, it's not wrong to just plug these numbers in here. I'm just noticing, oh, hey, these two kind of have some of the same pieces. I should be seeing the same numbers showing up again. And I'll do the same thing here. plug in -2, -1, 0, 1, and 2, which would be -1/2 times -2 squared. We already did -2 squared, it was 4. If we multiply that by -1/2, we're going to end up with a -2. And I'm just going to shortcut now. We should end up with numbers like -1/2, 0, +1/2. Sorry. This is what happens when you skip steps. You write down things that are wrong. I said 1/2 and then realized, oh no, it's supposed to be -1/2 times a 1. So my apologies, but I think these are all the correct numbers now. Okay, so when I go to draw the graph, notice I'll do them on separate graphs. I won't try and put them all in the same picture. But notice over here we have x is going from -2 to 2, and y's are going from 0 to 4. So that means we're really only seeing positive y's. We only need the top half of our coordinate plane. So I'm going to draw my axes like this. So I have more positives and not worried about the negatives at all. Not worried about negative y's. So then when I graph, we have points -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Okay, and the shape of this, I think I mentioned before, but this shape is called a parabola. Okay, if we draw the next one, same story. Our y's are all positive numbers, 0, 3, and 12. So I am going to have to stretch it out a little bit. It's not going to be able to fit on a graph this size, so let's maybe draw our tick marks a little bit smaller. Okay, so we counted up to 12. Our first point is -2, 12, -1, 3, 0, 0, 1, 3, and 2, 12. And so this is g of x equals 3x squared. The shape is also a parabola, but you'll notice it's a little bit different shaped. It's either compressed horizontally or it's stretched vertically. It's taller than the other guy was. And probably that's because we multiplied the heights by 3. Anyway, if I draw this one, notice I'm going to have to start off a little bit differently because all my y's in this case are negative numbers. So instead of doing the top half of the xy plane, I'm going to draw the bottom half since all my points should be down here somewhere. Okay, so let's draw -1, -2, +1, +2, and it looks like vertically we only have to go down to -1 and -2. So our first point is -2, -2, -1, -1/2, 0, 0, 1, -1/2, and 2, -2. Okay, and one downside of the way I'm doing this, the fact that each of my tick marks is slightly different sizes, is that it's not really obvious the relationship between these two shapes. First of all, it should be obvious that it's upside down, right? Instead of doing this, we're doing this. But it turns out also this one is going to be a little wider. It's more of a wide, short parabola instead of this guy, which is taller. So let's see, why are these things slightly different? Notice 2 out of the 3 are going upwards and 1 of the 3 is going downwards, and you'll notice that's because 2 out of the 3 have positive numbers in front of the x squared, 1 has a negative number. So it's the negative that's making us get upside down parabola shapes. Okay, so I think that's an important thing to note. So let's get a new piece of paper and write down some observations between these 3 graphs. Okay, so for a simple function like f of x equals a number times x squared, if a is a positive number, then it seems like the shape we're getting is a parabola that opens upwards. If a is a negative number, then we're getting this shape, which is an upside down parabola. And so I'm going to describe that as opens downwards. So we either have a bowl shape or an upside down bowl shape, and it's all based on the number a. And it turns out, if we think back to the original notation of quadratic functions, yoink, f of x was equal to ax squared plus a number times x plus a number. It turns out the same thing is still going to happen. The number in front of x squared is going to determine whether a quadratic function opens upwards or downwards. So the same is even true even if I change this to say plus bx plus c. Still, a being positive means it opens upwards, a being negative means it opens downwards. So if we just want a couple of quick examples of that, if I were to graph, say using a graphing calculator or making a table, 4x squared plus 3x minus 7, the fact that a is 4, which is a positive number, would tell me that the graph opens upwards. If we had f of x was equal to 3x minus x squared, notice this is written in a kind of funky format. We're used to seeing a number times x squared, then a number times x, then a constant. So I might want to rewrite this and say this is negative 1 times x squared plus 3x plus 0. So like if I was, same strategy as if I was doing quadratic formula and I wanted to know what is a, b, and c. The a is negative 1, which for us in this context means that our a is a negative number, our x squared is upside down, or it's the negative x squared, and so we're going to have this open downwards shape. Okay, I think that's where I want to stop the video, this first video. It's basically just the notation on quadratic functions, some examples of what simple graphs would look like, and then talking about how do we determine whether a graph is going to open upwards or downwards. And it is basically just look at the number a. Okay, that's it for this one.